We are going to work through the problems in section 1.1 of our text. This was a review section, and I picked out some of the problems that gave some people trouble. Let's first look at problem 1, surprisingly. And here it is. Determine whether the correspondence is a function. Now remember, for a function you need an input and it has to go to a definite output, no ambiguity. So if you look at this picture, even though 16 and 7 both go to 21, it is still a function. Remember our example from class, that state is a function of senator. So if you input a senator, then they represent only one state, even though two senators would have arrows to each state. So state is a function of senator, where two different inputs go to the same output, like in this example. So this actually is a function. Let's look at problem 3, which was another one. Here the domain, each person in a town, and the correspondence is each person's aunt. Is this relationship a function? So the input is a person in a town, and the output would be the person's aunt. Now you know that some people have more than one aunt. You might in fact have more than one aunt yourself. So if you input a person, that person might have two different aunts. So that would not be a function, because when you input a person, you're not sure which output you are going to get. So this would not be a function. Okay, let's look at the next problem that some people had trouble with, and that was problem number 12. So let's move up to that one. Find the domain of the function. Well, remember, for domains we had the big three trouble areas, and the big three trouble areas were dividing by 0, taking the square roots of negative numbers, and taking the logarithms of negative numbers, or 0. And this meets the first one. We have a function where if you input x equal to 0, you would be dividing by 0. So 0 is not an allowable input. Now they want you to type your answer in interval notation, so let's take a look at that. So let's input our answer in interval notation. So we need negative infinity, so we'll use the palette for infinity, comma, to 0, close the parentheses, and also from 0 to infinity. But we need our union symbol for that, union 0 to infinity. And close the parentheses. Notice they're both curved parentheses because 0 is not included and infinity is never included. And there you can see. The next problem that some people had trouble with was number 22, so let's move up to that one. Express the set in the simplest interval form, and then they give you that intersection of intervals. So let's take a look at this one. So what we have is the interval negative infinity to 5 intersect negative 6 to infinity. Now looking at this on the number line, we have negative 6 here, we have 5 here. So the first one, negative infinity to 5, comes up to here, and we are intersecting that with negative 6 to infinity. So that would be this. So clearly here is our overlap region. And let's check the endpoints. So we have minus 6 to 5, and let's double check the endpoints. 5 is in the first interval, 5 is in the second interval, so it's included. Negative 6 is in that interval, and negative 6 in there, so it is also included. So that will be our solution. Now for this one we need square brackets, so let's use the palette here. More. Square bracket. Negative 6, comma, 5, and we will use the palette to end the square bracket. And we can check. Okay, the next problem that gave some people trouble was problem 27, so let's go take a look at that one. So a cylindrical water tower with radius 14 and height 55 is filled to the height of h. The volume is given by that function there. Determine the appropriate domain. Identify the independent and dependent variables. So let's take a look. So the volume is given by the function g evaluated at h is 196 pi h. So this notation right here tells you that h is the input. So since h is the input, that is the independent variable. So we are looking at part B here, and now we have to figure out the domain. What does h range from? Well, it's a cylindrical water tower, and it has a height of 55 meters. So here's our water tower. There's the height. Well, clearly it goes from 0 because you can't have a height anything less than that. And the maximum height is 55. So that would be our domain. So it's part B. So we will select part B. And the domain is, we will use our square brackets again. Zero, comma, let's try the square bracket on the keyboard to see if that will work, comma, 55. Let's see if it allows that. Yes, it did. So we can use the square brackets on the keyboard. The next one that gave some people some trouble is 28, so let's take a look. We have two functions, and we would like to find the composition. So let's take a look at that one. So we have two functions. G of x is x to the fifth, and capital F of x is 1 over x minus 8. And we would like to find f evaluated at g evaluated at y. Okay, that means g comes first, and then the output of g gets put into the input of capital F, so we have 1 over g of y minus 8. And then we replace g of y with what it is, so we have 1 over y to the fifth minus 8. So let's put that in. So we have a fraction here. Let's use the fraction button in the palette. So we have 1 over, use the tab, y to the fifth, so y will use the exponent to the fifth, although it looks like I made a capital Y by mistake there. So let's try that again. There we go. Y to the 5th. Use the right arrow key to get out of the exponent. Minus 8. And let's check. All right. And the next one that gave some people some trouble was 31. So let's go take a look. Simplify the difference quotients for the given function. This will be something that's very important for us. So our function is f of x is 19 divided by x. So let's do the first difference quotient that they ask for. F of x plus h minus f of x, all divided by h. So let's get started. F evaluated at x plus h just means you replace the input with x plus h. So we have 19 over x plus h minus f of x, so that's 19 over x, and then the whole thing divided by h. So the simplification will come with getting a common denominator in the numerator, so let's work with that. The common denominator will be x times the quantity x plus h. So let's take a look at that. So we have 19x over x times the quantity x plus h minus 19x plus h over the quantity x over x plus h times x plus h, sorry. So there we just got a common denominator in the numerator. Now we can put these together. So 19x minus 19x minus 19h. Notice that negative sign there gets distributed among all of those. All divided by, I'm going to combine these into one fraction now. H, x, x plus h. And then, of course, the 19x cancels each other out. So what do we have? Minus 19h divided by hx, x plus h. And then, of course, we cancel out the h. So let's enter that in. It's a fraction, so we need the fractions from the palette here. So we have negative 19, tab to get to the denominator, x times the quantity x plus h. And let's check. Now they want the other form of the difference quotient, so let's work on that one. So again, the same function. F of x is 19 over x. So now we want f of x minus f of a over x minus a. So f of x is just 19 over x. F of a is 19 over a, all divided by x minus a. And again, we need a common denominator in the numerator. The common denominator would be ax. So that would be 19a over ax minus 19x over ax, and then all over x minus a. So when we subtract, we have 19a minus 19x over ax, all over x minus a. We can combine this into one fraction now, 19a minus 19x, all over ax, the quantity x minus a. Since we're simplifying, we can factor out a 19. And you'll notice we have an a minus x and an x minus a, which are opposites of each other. So we can cancel that out and include a -1. So it looks like we have -19 over ax. So let's check. Again, we have a fraction. -19 over ax. So let's check. All right. And then finally, some people had trouble with 32. So let's take a look. Oh, it's another difference quotient. So hopefully by seeing the first difference quotient, you have a better handle on this one. So I'll leave that one to you. So that is a run through some of the problems in 1.1. And I hope that was helpful.